In this lecture, we are going to cover Ohm's law, Kirchoff's current law, Kirchoff's voltage law, and one worked example. Let us discuss Ohm's law. Ohm's law states that the electrical current flowing through any conductor is directly proportional to the potential difference or the voltage between its ends, provided the temperature remains constant. So let us consider a conductor. So this is a current carrying conductor. So now a voltage source V is connected across this conductor. So this voltage source is a DC voltage source. Here the battery is connected. The battery comprises of two terminals. One is a positive terminal, another one is a negative terminal. Okay. So the current always starts flowing from the positive terminal. It is a conventional current direction. Okay. We should always mark the current to be flowing from the positive terminal of the supply voltage. So now Ohm's law states that this current which is flowing through the conductor is proportional to the voltage. Okay. So if we increase the voltage, the current also increases, and similarly if we decrease the voltage, the current also decreases. So the mathematical expression is given by V is directly proportional to I. Okay, or I is directly proportional to V. Now we'll introduce a proportionality constant called the resistance R, and the above equation will become V is equal to R into I or I into R. So this can again be written as V by I is equal to R. This ratio between voltage and current will remain constant. So the main condition for applying Ohm's law is the temperature of the conductor should remain constant. So the Ohm's law can also be stated in such a way that V by I ratio will remain constant provided the temperature remains constant. Okay. So here R is the resistance of the conductor in ohms, I is the current flowing through the conductor in ampere, and V is the voltage or the potential difference measured across the conductor in volts. Okay. So next we will see Kirchoff's current law. Now the Kirchoff's current law states that the algebraic sum of all the currents at any node point, so this node point or a junction of a circuit is 0. So let us consider a node. Here this is a node. Here these are the elements connected to the node. Okay, various elements. So this element can be a resistor, capacitor or inductor or any other thing. So now let us assume that I1 is the current entering the node, I2 is another current entering the node, and I3 is the current moving away from the node. So these two currents are flowing towards the node, and this I3 is assumed as flowing away from the node, and similarly another current I4 moving away from the node, I5 moving away from the node, and finally I6 entering the node. So here I1, I2 and I6 are moving towards the node. Similarly I3, I4 and I5 are moving away from the node. So if the current is entering towards the node, we assume it as a positive value, and if it is leaving the node, then we will assume it as a negative value of things. We will get the Kirchoff's current law. So now Kirchoff's current law is I1 plus I2 minus I3, because here I3 is leaving. Okay, similarly minus I4 and minus I5, these three currents are leaving, and so we take it as a negative current, negative value, plus I6 is equal to 0. Okay, as I said, the direction of the incoming current is taken as positive, while the outgoing currents are assumed as negative. So again, the equation 1 can be rewritten as I1 plus I2 plus I6 will be equal to I3 plus I4 plus I5. So these three are some of the incoming currents. These three are some of the outgoing currents. So at a particular node, some of the incoming current is equal to some of the outgoing current. So this is another statement for the Kirchoff's current law. Okay, the algebraic sum of the currents entering a node must be equal to the algebraic sum of the currents leaving the node in an electrical network. Okay, so next we will see Kirchoff's voltage law. So Kirchoff's voltage law is applied to a closed circuit. So this closed circuit is sometimes called as a mesh or a loop. So in a mesh or a loop, the algebraic sum of all the electromotive forces. So this is a voltage applied, and the voltage drops in resistors is equal to 0. That is, sum of the voltage rise is equal to sum of the voltage drops. So now let us consider a simple circuit. Here R1 and R2 are the resistors, and E is the supply voltage. Here again E is assumed as a DC supply voltage. Okay, whenever the voltage is applied across a circuit, current will start flowing. So this is the conventional direction of the current. So you should always mark the current to be flowing from the positive terminal of the supply voltage. Okay. So this ABCDA is a loop or the mesh or any closed circuit. So now let us consider I is the current flowing through this circuit. So in order to apply this voltage law, we have to assume the current always in clockwise direction, because this clockwise direction will reduce certain error if we go for complex circuits. Okay. So always remember to assume the current in clockwise direction. So if we assume the current in clockwise, then the direction of this arrow is from negative to positive with respect to this voltage source. So if it is the case, then this voltage is considered as a voltage rise. Okay, I repeat, if the direction of the current is from negative to positive with respect to voltage source, then it is assumed as voltage rise. On the other hand, if the same current flows from positive to negative with respect to voltage source, then it is assumed as voltage drop. And similarly, voltages across the resistors are considered as voltage drops. So now we have to find out the voltage rise and voltage drops for applying Kirchoff's voltage law. So now we'll write voltage rise is equal to E. So why? Because the direction of the current is from negative to positive. So now we have to write the voltage drop across the resistor R1. So we can apply Ohm's law here. I is the current and R1 is the resistance value. So by Ohm's law, V is equal to I into R. So the voltage drop across the resistor R1 can be written as I into R1. And similarly, voltage drop across this resistor R2 can be written as I into R2. So next we have to add these two voltage drops, I into R1 plus I into R2. So this is equation number 2. Now by KVL, sum of the voltage rise is equal to sum of the voltage drops. So we can equate these two equations 1 and 2. Okay, one equation is voltage rise E, two equation is I R1 plus I R2. So it is written as E is equal to I R1 plus I R2. So this is a Kirchoff's voltage law equation. So now let us solve this particular problem. In a network shown in the figure, find the value of current flowing through the circuit by applying Kirchoff's voltage law. So this is a given circuit. Here DC supply voltage is given. Its value is 12 volts. Resistor R1 value is given 10 ohms and R2 value is 20 ohms. So now whenever the voltage is applied across the circuit, current will start flowing from the positive terminal. So we should always mark it in such a way that it should flow from the positive terminal of the battery. Okay. So now we have to assume the current to be flowing in the clockwise direction inside this particular loop. We have only one loop and so we have one current. This current is assumed to be flowing in the clockwise direction. So now by applying Kirchoff's voltage law, we have to write both voltage rise as well as the voltage drops. So now this current direction is from negative to positive with respect to voltage source. So this is defined as a voltage rise. So voltage rise, we should write it with respect to voltage source only. Okay. So here we have only one voltage source and that too the current direction should be from negative to positive. So then it is called as voltage rise. Otherwise it will be voltage drop. So if the current will be in the reverse direction. Okay. So next we have to write the voltage drop across the resistors. Okay. Voltages across the resistors are always assumed as voltage drops. So now voltage drop across 10 ohms is I into 10 or 10I. So we have to apply Ohm's law here. Okay, V is equal to I into R. Similarly, voltage drop across 20 ohms resistor is I into 20, that is 20I. So now we have to add these two voltage drops up, 10I plus 20I. So this will be equal to 30I. So this is equation number 2. Then by Kirchoff's voltage law, we can equate this voltage rise and voltage drops. So we can write 12 is equal to 30I or 30I is equal to 12. And so we get I is equal to 12 by 30 or 0.4 ampere.